Welcome to today's Explainer, where we are going to dive deep into the foundational logic of programming and show you exactly how to structure an exam answer that will absolutely blow the examiner away. If you're studying for your Cambridge Computer Science exams, you know that facing a blank page for an algorithm question can feel like navigating a total wasteland of tricky requirements and hidden traps. Today, we're going to give you the ultimate strategy to claim your grade treasure. We are using official source material to decode exactly what separates a top-tier, A-star programming paper from the rest of the pack. Are you ready to level up your code? Let's get right into it. We have a packed strategy session ahead. We'll be building your knowledge step by step, starting with the building blocks and controlling the flow, moving through strings, functions, and arrays, and then wrapping up with a massive exam showdown where we analyze real code. Let's kick things off with Section 1, the building blocks. To architect an incredible, bug-free piece of software, we first need to understand where our data actually lives inside the computer's memory. Okay, let's really dive into this concept because it is the bedrock of everything else we'll do. Think of a variable as a labeled box sitting in the computer's RAM. The contents of this box can be swapped out or updated as your program runs. It's entirely dynamic. If you're building a game, your player's score is a variable. It might start at 0, but it's going to change to 10, then 50, then 100. But remember, the absolute golden rule across nearly all programming languages, and especially in your Cambridge pseudocode, is that you must always declare that variable before you use it. If you don't tell the computer the box exists, it's going to throw a massive error. Now, by contrast, a constant is totally locked in place. Once you assign a value to it at the very start of your program, it stays exactly that way permanently throughout the entire runtime. Think of things like pi in a math program, or a fixed tax rate in a financial application. Examiners love testing this concept. If you try to alter a constant later in your code, your program will simply crash. Using constants is a massive green flag to an examiner because it shows you understand how to protect critical data from being accidentally overwritten. We have to explicitly tell the computer exactly what kind of data is going into these variables and constants using fundamental data types. This is absolutely crucial because it tells the computer whether it can perform mathematics on the data or if it should just read it as plain text. For example, if you store the number 25 as a string, the computer treats it like a word. That means you literally cannot add or subtract from it. Knowing these 4 basic types, integer for whole numbers, real for decimals, string for text, and Boolean for simple true or false flags is absolutely non-negotiable for passing your exams. Moving right along to Section 2. Now that we have our data neatly packed and declared in variables and constants, let's look at how we control its movement through our program's logic. Before we continue, subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's talk about grabbing data safely. You must always direct the user with a clear prompt first. If they don't know what to type, they'll type the wrong thing, right? Using this exact 4-step sequence ensures that bad data never breaks your program. You output the prompt, you accept the input, you immediately check that input against your rules, and if it's wrong, you loop right back and force them to do it again. This creates a bulletproof safety net. To validate that input or to process long lists of data, we use iteration, which is just a fancy word for loops. Notice how the underlying logic remains completely identical across languages, even when the specific syntax shifts around. We have count-controlled loops like the for loop, which we use when we know exactly how many times we need to repeat an action. Then we have precondition loops like the while loop that check a specific rule before the code even runs once. And finally, postcondition loops like repeat until, which guarantee the code runs at least one time before checking the rule at the very end. Choosing the right loop for the right scenario is exactly what examiners are grading you on. Section 3 brings us to text. Let's dive deep into how we manipulate strings, which is a wildly common task in both real-world coding and in your exam papers. These 4 standard string handling methods are essential tools in your developer toolkit. You'll use length to check if a password is long enough, and upper or lower to format names consistently. But listen closely, because I really want to highlight a massive trap here. You need to keep a close eye on the index. When you are extracting a substring, Cambridge pseudocode starts counting characters at position 1, but modern programming languages, like Python and Java, start counting at 0. Forgetting this tiny detail is a classic, painful way to lose points on an otherwise perfect algorithm. Always double-check your index. Which brings us to Section 4. As our programs get larger and more complex, we simply cannot keep writing one massive, terrifying block of code. We need organizational tools to make it efficient and readable. Procedures are absolutely brilliant because you define them just once, and then you can call them as many times as you need. This saves you from repeating the exact same code over and over again. For instance, if you need to print a fancy border of stars across the screen multiple times to separate menus in your game, you don't copy and paste the print statements. You just write a print stars procedure and simply call that name whenever you need the border. It makes your code so much cleaner. Now, a function is exactly like a procedure, but with one absolutely crucial difference. It hands a specific result back to the place where it was called. Think of it like a specialized calculator. If you write a block of code to convert Celsius to Fahrenheit, you want your main program to actually receive that converted number so it can be displayed on the screen or saved to a file. Because it returns a value, that is when you must use a function instead of a procedure. Stop scrolling, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
This quote right here, straight from the source material, is the ultimate golden rule of coding. It leads us directly into how to make your code truly maintainable.
If you follow these 3 guidelines, not only will your future colleagues thank you, but the Cambridge examiners will absolutely love grading your papers. Think about it. If you name a variable just the letter T, literally nobody knows if that stands for time, total, or temperature. It's a guessing game. Call it total weight. Add some clear comments explaining your logic, organize everything into neat modular procedures and functions, and your code magically becomes a joy to read. This is how you secure those top-tier marks. Moving into Section 5, which is all about arrays. When you have 50 students' grades to store, you definitely don't sit there creating 50 separate variables. You use an array to instantly organize that complexity. A one-dimensional array is just a simple, straight list of items. It's great for storing a list of high scores. A two-dimensional array, however, acts much more like a spreadsheet or a table, complete with rows and columns. This allows you to cross-reference complex data using multiple indexes. It's incredibly powerful for keeping related data, like a player's real name, mapped directly to their in-game nickname, safely linked together in memory. Mastering arrays is what elevates you from a beginner to an advanced programmer. And now for the absolute climax of our explainer here in Section 6, we are going to step directly into the shoes of the Cambridge examiner. We're going to look at 2 drastically different student attempts at the exact same past paper question. Let's see what a real strategy looks like. The exam question asks students to write an algorithm to store player names, ages, and nicknames. They have to strictly validate the inputs, allow between 3 and 5 players to enter data, and finally, output a sorted welcome message for each player based on their preference of using their real name or their nickname. It's a very hefty prompt with a lot of command word requirements. Let's see how our 2 examples handled it. Looking at these side by side is incredibly revealing. Let's look at the low-level answer. Let's imagine a student named Sam wrote this. Sam clearly rushed. The code literally copy-pastes the same block of input text 5 times. The variables are poorly named N1, N2, and A. What do those even mean? There's no true loop for validation, just a weak warning message if the input is wrong, which totally misses the exam requirement. It's chaotic. Whereas the high-level answer, the true strategist's blueprint, elegantly uses a repeat loop and a 2D array to do all the heavy lifting, completely avoiding that messy copy-pasting. It is so much cleaner, and it perfectly follows the PEAL framework, point, evidence, explanation, link, and how the logic is structured. The examiner awarded top marks to the high-level answer right here, specifically because the student created a flexible, professional blueprint. They used a bubble sort algorithm to correctly organize the array data by age without breaking the links to the nicknames. And they used crystal clear if-else branches to decide whether to print the player's name or nickname. It was readable, perfectly indented, and it checked off every single command word in the prompt. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. So the crucial point today is that mastering basic syntax just isn't enough. You can memorize every keyword in the syllabus, but you must demonstrate to the examiner that you can architect a maintainable, organized solution. You have to let the arrays and the loops do the hard work for you. Remember, you always write code for human eyes first and the computer second. You now have the ultimate blueprint to turn chaotic code into top-tier logic. So the next time you sit down to write an algorithm, ask yourself, are you just writing basic syntax or are you architecting a masterpiece? Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the exams. Your Cambridge success starts here.